Hello everyone and welcome to Say It with the Symbols 3.4. This will begin on page 52 of your textbook. Our learning targets again for Investigation 3 are we'll be able to solve linear and quadratic equations and begin to explore systems of equations. Our ACES problems for 3.4 include 27 through 29, 31 through 34, 42, 49 through 52, and 59. So as we turn to page 52 in our books, we are just going to continue on with our quadratic equations, solving those and finding some of the x-intercepts along with that. So for part B here, it tells us, and we're skipping part A. We're doing B, C, and D for today. And it says solve each equation for x without making a table or graph. Excuse me. So to solve, we have to set each of these equal to 0. And we've done this before, but just for a quick review, I'll do number 1 for you. So if we have x plus 1 equals 0, then we're going to go ahead and subtract 1 from each side, and we wind up with x equals -1. The other part would be 2x, and I'm just not going to put the parentheses on it this time. 2x plus 7, okay, equals 0. And we're going to go ahead and subtract 7 for both of these, and we get 2x equals -7. If we divide both sides by 2, we get x equals -7/2. Okay, x equals -7/2. Now, if we wanted to test and make sure that these answers were correct, we could plug them in one at a time back into the equation and see if we come up with 0. Well, if we take -1, we plug it in. -1 plus 1 is 0. -1 times 2 is -2 plus 7 is 5. But 0 times 5 is 0, because 0 times anything is 0. So 0 would equal 0, and that would be a correct answer. You could go ahead and check out the other one as well on your own. So these two are already factored, 1 and 2. 3 through 6, you need to factor those and then solve for x. As I said, to check these, we just plug our answers back in and see if we wind up getting an answer of 0. C is going to be more of the same sort of problem solving. You'd have x equals 0 and 9 minus x equals 0. Solve for x for each of those. Factor these out. Just more continued practice there on C. In D, it asks you a little more involved question. It says approximate the height h of a pole vaulter from the ground after t seconds, and this is going to be a lot like on your test for frogs, fleas, and painted cubes, where they shot the flare in the boats, or how high one of the animals could jump, those sorts of things. So that's what you're going to be doing with 1 and 2 here, is just like that with frogs, fleas, and painted cubes. Now, I went through all of that kind of quick because I wanted to get to this part here at the end. And on page 54 in your book, there's a little did you know, and it talks about other ways that mathematicians can go about solving quadratic equations. It says, for years, mathematicians tried to find a general solution to ax squared plus bx plus c equals 0. And in a book published in 1591, Francois Viet was the first person to develop a formula for finding the roots of a quadratic equation, and it is called the quadratic formula. And that is what this is. And this is just the proof of ax squared plus bx plus c. Someday maybe I'll take the time to show you exactly how this got arrived at, but I'm not going to take that time today. But remember that all of our quadratic equations are in the format, okay, of ax squared plus bx plus c. Okay, ax squared plus bx plus c. So 2 is our a here, 7 is our b, and 6 is our c. So we're just going to go ahead and plug those in here, and then we'll go ahead and see what our x-intercepts are for this. So we would have negative b, negative is 7 is our b, so we'd have -7 plus or minus the square root okay, of b squared, so 7 squared, okay, minus 4 times a is 2, okay, times c, which is 6, okay. So that's our numerator. We draw our line, and denominator is 2 times a, so 2 times 2, right? So we drop down, we have negative 7, okay, plus or minus the square root of 7 squared is 49, okay, minus 4, I'm going to go ahead and put my minus. 4 times 2 is 8, 8 times 6 is 48, okay, so we have 49 minus 48 here, divided by 2 times 2, which is 4. So go down again, we have negative 7, okay, plus or minus the square root of 1. 49 minus 48 is 1, and all of this is over 4. Well, square root of 1 is 1, so we have negative 7 plus or minus 1 over 4. Okay, so if we go negative 7 plus 1, for that one, we have negative 6 over 4. Okay, and for the negative 7 minus 1, we have negative 8 over 4, okay, which is just negative 2. So we have negative 1.5 and we have negative 2. Well, if we take either one of those, okay, I'll write them down here. See, a 1.5, negative 2. Those are our two x-intercepts, okay? That's what we're finding here, x equals. So when y is 0, x equals. These are your two x-intercepts that you're going to find. And to prove that, you could plug either one of these back into our equation. Let's just take number 2 because it's easy. Well, 2 squared is 4. 4 times 2 is 8. Okay. Negative 2 times a positive 7, we're going to have negative 14. Okay. And then plus 6. Well, 8 minus 14 plus 6 all winds up equaling 0. So we know that that proof works. If you want to check on negative 1.5, you can do that. But this is the quadratic formula right here, and that's the way to find your x-intercepts. Hope that helps you out. Look forward to your questions and comments in class. Oh, by the way, we'll go over the aces again real quick for 3, 4, 27 through 29, 31 through 34, 42, 49 through 52, and 59.